Alright, so I think I'm recording. We're taking a look at skill packet 5, which is exponential and logarithmic functions, and in skill 5G we're solving exponential and log equations. Here in number 9, we have an equation. On the left hand side we have two terms, on the right hand side just a single term, a constant. The two terms on the left, the first term has the variable of interest, so I need to get that by itself first of all. So we'll add 4 to each side of the equation. So we've got by adding 4 minus 2 is 2. Now, we can't rewrite these to have the same base. We had a previous homework assignment where you would get the bases the same, and since it was a one-to-one function, the exponents would have to be the same, but we can't do that here. We can use logarithms. Let's go ahead and take the common log of each side, and the reason we do that is because with the properties of logarithms, we'll now be able to deal with this exponent. We've got a power rule that says when you have the logarithm, when the argument has an exponent on it, you can take that exponent down as a coefficient. So now on the left hand side I have two factors, and one of the factors is of interest because it's my variable. I need to get this factor by itself, so I need to divide both sides of the equation by log of 6. And so I have that x is log of 2 over log of 6. If I want a decimal approximation, I can go to a scientific calculator and fix the mode to however you want to round it. And in this case, it's rounded to 3 decimals. Don't forget to close your parenthesis. So 0.387 is an approximation to this. So I claim that if we have 6 raised to that power, if we have 6 raised to the 0.387 power minus 4, I'm not, because of round off error, I'm not going to get exactly -2, but I'm going to get something pretty darn close. So here I've got something that's almost -2, so it checks. Let's take a look at this problem. Now here already, the term that has my variable is already by itself, and I can't do things to get the x by itself without using properties of logarithms, and the inverse of an exponential function is a logarithmic function. Since the base is e, I'm going to take the natural log of each side. So by those first 4 problems that was on this homework, we know this left hand side is just 1 minus 4x. If you don't recognize that, by the power rule, 1 minus 4x comes down, and now hopefully you recognize that the natural log of e is just 1, because this logarithm is an exponent. E to what power is equal to e? E to the first power. So on the left hand side we're just left with this 1 minus 4x. On the right hand side we have this number that's the natural log of 8. So I need to, on the left hand side I have two terms. The term of interest is the second term, and I need to get it by itself. So I'm going to subtract natural log from both sides and add 4 to the x to both sides. Now on the left hand side, that term has two factors. I need to get the factor of x by itself, so I need to divide both sides by 4. And I have a final answer of this numerator, 1 minus the natural log of 8 divided by 4. I can go to a calculator, get a decimal approximation for this. Let's put parentheses around that numerator. Don't forget to close the parenthesis for the logarithm, and don't forget to close the parenthesis for the numerator, and now divide it by 4. So I get negative 0.27. So I hope that helps. I'll continue doing these in pairs. So talk to you later.